we want to simplify some expressions that involve exponents. Here we have x to the 7th divided by the quantity 3x to the 3rd power. So here, the bigger exponent is on the top. So we are applying this first property here, which says that if a is greater than b, if the exponent on top is bigger, we're going to subtract the bottom exponent from the top exponent. So this is going to become x to the 7 minus 3, and the 3 is going to be left on the bottom. So the x to the 3rd essentially moved to the top and is subtracted from the 7. So x to the 7 minus 3 becomes x to the 4th over 3. Now let's try a second example. We have x over the quantity 2x to the 4th. So first we're going to apply the property that says the denominator would be 2 to the 4th over x to the 4th. So that's x over 16 x to the 4th. Now the exponent on the bottom is bigger than the exponent on the top. So x to the 4th is bigger than x to the 1st. So we're looking at the second property. If b is bigger than a, if the bottom is bigger, then we're going to subtract the smaller exponent from the bigger one. That's the general rule. Wherever the bigger one is at, we're going to subtract smaller from bigger. So this is going to be a 1 left on the top from the coefficient in front of x, 16x to the 4 minus 1, or 1 over 16x cubed. In these next two examples, we have some negative exponents. So I have 3 times x to the negative 2. A simplified answer doesn't have any negative exponents. So the general rule is that the variable that's attached to the negative exponent is going to move to the other side of the fraction bar, and then the exponent will become positive. So 3x to the negative 2 is going to be 3 over x to the positive 2. So it moved to the denominator and became a positive exponent. The 3 already has a positive exponent. That's 3 to the 1st. So the 3 stays in the numerator. It is not attached to the exponent negative 2. For the second example, x to the negative 2 is in the denominator. I have 1 over 3 times x to the negative 2. To make this a positive exponent, I'm going to have to move that x to the numerator. So I'm going to have x to the positive 2 over 3. Again, the exponent for the 3 is positive 1. It is not attached to the negative 2, so the 3 stays in the denominator. And here we want to simplify 3x cubed all over x to the negative 4 times x squared. Let's simplify the bottom first. These have the same base, so we would add their exponents. So I have 3x cubed over x to the negative 2. And now I don't want any negative exponents. So x to the negative 2 would move to the numerator and become x to the positive 2. So I have 3 times x cubed times x squared. And then in the denominator, there's just a 1. So now these have the same base. We can add their exponents. So this becomes 3x to the 5th power. Another way we could have arrived at the same answer is recognizing that 3 is bigger than negative 2 and applying this property, which says that this would be 3x cubed minus negative 2. Minus minus is plus, so this would be 3x to the 5th. And finally, 3/4 to the negative 2. Well, what we could do here is switch the numerator and denominator, or take the reciprocal, 4/3 raised to the positive 2. And so this would be 4 squared over 3 squared, which is 16 divided by 9.